Good morning, class. Today we are going to start chapter 6, which is working with quadratic equations. In the beginning of this lesson, we are going to look at 6.1, and your objective for today is to be able to multiply two binomials by each other. A binomial would be something like this. If you had ax plus b times cx plus d. So that's our ultimate goal for today, and we will do this just by looking at a bunch of examples. So basically, when we're multiplying binomials, first of all, if you see the language find the product, just remember product means to multiply. We're going to start without doing binomials. Instead, we're going to take a constant times a binomial. And we've done this in the past, and the biggest thing you want to do is you want to be able to take the constant out front and distribute it through. So we've been doing this in problems we've already been doing, but so basically I would take the 3. First, I would distribute it to the 7m, so I'd have 3 times 7m. Then I would distribute the 3 to the negative 1. Now, remember to be careful with negative signs. So it'd be like taking a plus 3 times a negative 1. When I do this, then 3 times 7m, 3 times 7 is 21, keep the m attached, and then a 3 times a negative 1 would be minus 3. So in this case, when we did 3 times 7m minus 1, I get 21m minus 3. Now, as I said, we've done this in the past when doing algebra. Now we're going to continue to build up to where we're going. The next situation we could have is if you still have a monomial, which is just a single term times a binomial. So you can see the monomial here is 4x. Now, if I have a 4x times the rest, I would still take that and distribute it through to both things. So again, I would have 4x times x. Again, we have to be extra careful with the negative sign, but I'd have plus the 4x times the negative 8. Again, just be careful with your negatives. And now when I look at this, 4 times x, I only have the constant 4, so I'm going to keep that. And a big key for today is anytime you have an x times an x, it's going to be x squared. And then I have 4 times x times negative 8. Well, 4 times negative 8 is negative 32, and then again I just attach the x to it. So if we're just multiplying monomials by binomials, we're just going to use the idea of distribution. So now we're going to take it one step further, and we're going to start looking at the bigger picture of what we talked about. This is an example of multiplying a binomial times a binomial. Now, keep in mind, our directions haven't changed, meaning we're still finding the product, which means we need to multiply these together. Now, I'm going to introduce this by doing it the same way we've been doing, but then I'm actually going to change it on you and give you a strategy to use that might help a lot of you do it a little more successfully. If we use the philosophy that we were just looking at, we would take the thing that's in front and put it in a box like I did the others. Ultimately, what you do is you need to take the 7r plus 1 and distribute it through. So I'd have 7r plus 1 times the 2r, and I'd have plus 7r plus 1 times 2. Now, the problem with this is, as you can see, we still have a bunch of parentheses, so we're going to have to continue to distribute. Now, in this step, we could actually do what we might call reverse distribution, and we could now take the monomial, which in this first one is 2r, and distribute it back. So we could do 2r times 7r, and then I would also have to do the 2r times 1, so plus 2r times 1. And then I need to do the same thing. In this case, the monomial is 2. I would distribute that back, so I have 2 times 7r plus 2 times 1. So in essence, if you're doing a binomial times a binomial, you could do distribution 2 times, taking the 7r plus 1 as your term distributing through, and then individually you would take the monomials and distribute it backwards, in this case, to both binomials. Once we get here, again, we would do 2r times 7r. The 2 times 7 gives me 14. And as we talked about, anytime you have r times r, we're going to make that r squared. The next one, I have plus 2r times 1. The 2 times 1 gives me 2, and then there's just an r. And then in the next one, I have 2 times 7, which is 14, and then just the r by itself. And finally, 2 times 1 is plus 2. Now this goes back to on Friday, after you're done with your test, you were supposed to do the Khan Academy video for combining like terms. Like terms, remember, is when you have a variable to the same power. And if that's the case, you can combine them. As I look at this, I have variables, I have r's in it. If I look at 14r squared, there's no other r squared, so I'm going to keep the 14r squared. As I keep looking at my problem, I have a 2r and a 14r. Now because both of those have an r to the first power, I can combine those. So a 2r plus 14r is 16, because 2 plus 14 is 16, and then I just keep the r attached. And then finally, I have plus 2, the constant at the end. As you can see, multiplying a binomial times a binomial actually gives me a trinomial, which means it has 3 terms in the answer. Now, this particular trinomial is a quadratic. And that's key because, again, Chapter 6 is ultimately working with quadratic equations. A quadratic is an equation that has a variable squared. So in this case, because I have the r squared, it makes it quadratic. Okay, now let's take another example. And actually, let's look at this one again. I said there was going to be 2 different ways we could do this problem. This is option 1, what we just did. Oops, that's supposed to be 1. Option 1. Okay? Option 2 would be to use this thing called the box method. In the box method, if you have a binomial times a binomial, what you're going to do is you're going to take the first one and write it on top. So I'd have a 7r plus 1. I'm going to take my second one and I'm going to write it down the side. 2r. I have to make sure that I keep my plus with it, because if you have negatives, it's going to cause a problem. And I make a box, and between every number or term, I draw lines. So you can see I end up with a box with 4 pieces to it. Now, if you remember way back to when you started learning how to multiply, we had multiplication tables. Virtually what you're going to do with this is do your multiplication table. So if I take the 7r here times the 2r, so you're always going to multiply. And because those 2 are connected on that box, I would do 7r times 2r. Well, again, 7 times 2 is 14. R times r is r squared. So in this box, I would do 1 times 2r. So 1 times 2 is 2, and then the r. In this box at the bottom, I would take the 7r times the 2. 7 times 2 is 14, and I have the r. And then in the final box, I'd have the 1 times 2. So I'm left with 2. If you use this method, what it gives you is basically where we got to in this line, just in a different format. So now what I do is I combine like terms from the box. Well, you can see that in the upper left-hand corner, I have 14r squared. There's no other r squareds in any of the boxes, so that is my first term. Now notice when we start looking for the r's to the first power, I have a 14r here and a 2r up here. Well, 14 plus 2 is 16, and keep the r attached. And then finally, I have the constant in the bottom. You notice we got the same thing both ways, and I do believe that the box method can be a little bit quicker for students. Having said that, notice that it's always the diagonal that will be your like terms. Now, because I think this method is a little bit cleaner, the rest of the way I'm going to choose to use the box method with you guys. I do think it's important that you saw option 1 so that you understand that it's available to you, but I do think for our best success we will be looking at the box method.